Hi guys, we're going to have two videos for this first section of notes in Unit 8. Unit 8 kicks off talking about the rock cycle and about geologic processes. Today we're going to have two videos, one focusing on the rock cycle, the second one focusing on the geologic processes. You'll need to know both for testing, both in this unit, in your mastery checks, and also at the end of the year will be quizzed on this as well. So go ahead and check this one out for rock cycle. And after you're done, you won't be able to finish your worksheet without going to the next video and checking out the geologic processes video. Remember that you'll need to submit that worksheet at the end in order to get credit for completing the unit. Okay, so let's talk about the rock cycle. You've been talking about this since third grade, so it's probably stuff you know, and I'm going to go over the rock cycle pretty quickly because I don't think that it's something that is super mysterious, but we'll give some examples of rocks and talk about them. So there are three rock types. We have igneous rock, which is an example of that right here. We have metamorphic rock. There's an example of that right here. And we have sedimentary rock. There's an example of that right here. Now, the geologic processes, which we'll talk about in our next video, are actually the things or events that create these different types of rocks and actually are responsible for a lot of the changes we see on the surface of the earth. These geologic processes can be internal or external, meaning that they can happen inside the earth or they can happen on the Earth's surface. And we'll talk more about that later, but just keep in mind, those geologic processes are exactly what changes these different types of rocks from one to the other, or just makes those rocks in the very beginning anyway. All right, let's look at igneous rock. Igneous rock is our first rock type that we're going to talk about. This is when we start out with some sort of molten or melted rock material. This is probably magma in the mantle section of the Earth's layers, and it either cools and hardens on the surface of the Earth, or it cools and hardens inside the surface of the Earth. Because of those two different ways of cooling and hardening, we have two types of igneous rock. We have what's called intrusive igneous rock, which is formed from magma that cools and hardens inside the crust. And I remember that by just looking at the fact that this word starts with the word in. So it is intrusive, meaning that it is igneous rock that was formed inside the surface of the earth. So hopefully that's helpful. You can remember that word intrusive and know that that is rock that is formed inside the crust of the earth. Granite is a great example of intrusive igneous rock. It cools and hardens over millions of years inside the surface of the earth. And then as dirt around it erodes away, because it's very, very hard, that granite rock will be exposed. It can also be pushed up by earthquakes. So sometimes we'll see that granite pushed up through the crust, and we'll have it exposed there because it doesn't erode very quickly. And so we'll see that granite as a formed, what's called a batholith on the surface of the earth. You don't need to know that word batholith. It's just kind of a cool word. It sounds sort of fantasy driven. But anyways, it is granite rock, and granite rock is intrusively formed or intrusive igneous rock. We also have extrusive igneous rock, which is exterior to the surface of the earth on the outside of the earth. This is usually like lava flow, right? And there's lots of different types of lava, and lava forms lots of different types of igneous rock, but it's all extrusive. A couple of examples are this what's called volcanic glass or obsidian. It is usually black or maybe black with red flecks. It's usually sharp. It's usually sort of glassy and smooth. We also have pumice rock, which is very, very lightweight. It's, you can tell, once upon a time was full of air bubbles. This stuff is usually exploded out of volcanoes during eruption, and people use this in household chores. It helps to rub away scale and hard water deposits and things like that, like rust, stuff like that. So there's some examples of igneous rock, intrusive and extrusive forms. Next is metamorphic rock. Metamorphic rock is rock that starts out as some type of rock. It might start out as igneous rock. It might start out as sedimentary rock. It might even be another metamorphic rock. And then it's exposed to high heat and high pressure, maybe even hot mineral-rich fluids like acids and waters with chemicals in it. That will form a different type of rock now. It changes chemically in some way, and it will oftentimes also have physical changes. And those changes make it a completely different type of rock. So, for example, marble is a really good example of metamorphic rock. You can see that once upon a time it was sedimentary, but now it's very hard and very smooth, and it is marble. And marble is a metamorphic rock. Slate is also very hard and pretty smooth, especially when you consider that it started out as mud. People use this on their flooring or maybe around their fireplaces. It's usually black or dark brown, and it is also considered a metamorphic rock. Quartzite is all over Utah, especially this rose quartzite. We can see it everywhere. It is a metamorphic rock with its shiny parts and pieces that glint in the sun. And any type of precious gem is going to be considered a metamorphic rock. Diamonds, rubies, sapphires, these are all metamorphic rocks. And they were once upon a time another type of rock that were then subjected to super high heats and very high pressure, and maybe even acids and other mineral-rich fluids that changed the nature of those rocks and turned them into what we consider metamorphic rock, or the rock that they are today. Finally, sedimentary rock. This is when we have lots of different layers of deposited material, one on top of the other, or all pressed together, sometimes stacked on top of each other, but sometimes just sort of globbed all together in a big glob. And they will what's called cement and harden together and form a rock. So they start out as a bunch of little pieces, like maybe dirt or sand or dust. And then after time, those will layer up on top of each other or glue together and create a whole rock, right? So it starts out as small pieces and they come together to make a big piece. Sometimes those things, like I said, are sand or dust or clay, something like that, maybe small pieces of rock, fragments of rock. But we also will have organic material. So it might be leaves or sticks, maybe bones or other parts of decomposed flesh, like birds, bugs, small animals. Things like this can all come together and layer up together or be smooshed together to form sedimentary rock. A lot of times they're carried along by rivers and streams, and they're deposited in lakes and oceans, but they can also be carried by wind, and that can happen as well. So we have some different types of sedimentary rock. We have conglomerate rock with its larger chunks all pushed together. It looks kind of like asphalt, but it's actually made naturally. We have shale, which is the precursor to slate, which we talked about in the previous slide. And this was once upon a time mud, but now it's hardened and become rock, called shale. This is on like the backside of Ben Lomond Mountain. So I don't know if you've ever hiked the backside of the Divide Trail, but you can find shale there. It's pretty slick. It's kind of scary to walk on. And then sandstone. We're super famous for sandstone here in Utah. You can see these very obvious layers in the sandstone from the deposition of different types of materials all coming together and like sticking together to make this sedimentary rock. You see this in Zion National Park. You see it in Moab, around Arches National Park. Pretty cool stuff. We're super famous for it. So, okay, that ends this portion of our notes for today, and is all about the rock cycle. Make sure you answer all your rock cycle questions, and then jump to the next video about geologic processes.